Hello, class. I'm going to continue the lecture for statistics for section 4.3, covering the multiplication rules and the conditional probability. And so right now we're going over the last part of this section, the conditional probability. And I stopped on page 115 of your workbook. And this is an example of a conditional probability. And again, how do you know when we're doing this is because you have the given that included as a keyword. So at a large university, the probability that a student takes calculus and is on the dean's list is 86 thousandths. So tenths, hundredths, thousandths. The probability that a student is on the dean's list is 34 hundredths, so tenths, hundredths. Find the probability that the student is taking calculus given that he or she is on the dean's list. And so we have probability the student is taking calculus given that he or she is on the dean's list. Okay, so I've got that written out. And so I'm going to write down the formula. I have it up here at the top from the previous problem that we did, which was also a conditional probability problem. But I'm going to go ahead and also put the definition here. So probability of B given A is equal to probability of A and B over probability of A. So remember, it helps you remember that these, end up being the same, should be identical, okay? And also, when you start off, it's not alphabetical here, so B given A. So that means that this represents B. Students taking calculus, that represents B. Given that, so that's this bar here, he or she is on the dean's list, so that's the A. Okay, so oftentimes on your tests, I'll say, you'll see this, let B denote blank, let A denote blank. So I'm trying to get you to make a decision which subject is the B and which subject represents the A. So for us, uh, uh, taking calculus is going to denote the B. And then the A is going to denote being on the dean's list. And then when we substitute using the formula, probability in lieu of B given A, you're going to say calculus given A is dean's list. So you see I've shortened it. See, it's much longer here. So I shorten it, but there's your calculus, there's your given that, there's your dean's list. Okay, so now I'm going to substitute this part in. So probability of A, and remember A is dean's list, and B is calculus. Okay, and then all over probability of A is dean's list. Okay, and then I'm going to do my substitutions. And normally, the and, normally for the and, if you had a table, I would do dean's list and then and then calculus. And this is for these are for the outcomes, right? These are for your outcomes, the Dean's List outcomes, the calculus outcomes. And that's if you had a table. Like over here in this previous problem, probably of them voting no and being male, you had a table. And so I was able to get the outcomes. These were the outcomes, okay, for the no and the male from our table, right? So the no and then the male from our table. But you see, this problem doesn't have a table, and they actually give you the calculations as decimals. So we actually just need to, here we're going to actually use substitution since no table is present. Okay, so the substitution for the Dean's List and calculus, it's got to be one of these numbers. See these two numbers that they give us here? One of these numbers is for the Dean's List and calculus, and one of these numbers is for the Dean's List. So you see that 86,000, that's talking about student takes calculus and is on the Dean's List. So it's a little, they just mentioned it out of order, but this is still Dean's List and that's still right. So it's a little bit out of order because they mentioned calculus first, but instead of Dean's List, but that's okay. So that's a substitution for the numerator. Let me just lower this equal sign. And then the substitution for the Dean's List is this one. This is the Dean's List, 3,400. Okay, and then when I can use my calculator for that, let's see. 0.086 divided by 0.34. Okay, that gives me that. And then I'm gonna round this. I'm gonna round this to nearest thousands. So tens, hundreds, thousands. Then look at the number to the right. Is this 5 or more? Yep, it's a 9. So add 1, 2, 5, 3. Okay. Okay, and then on page 116, yeah, so this one I'm not going to try to put this into fractions or anything. They gave us, usually the rule of thumb is if it starts off with decimals and it's okay to leave it as decimals. So that's fine. But I'm not going to make that into a fraction or anything like that. It's okay. Stop there with that. Okay, so this is supposed to be a review. So, usually in a remote class or a face-to-face class, I would really ask the students questions about these problems. See how you have an or, and see how you have a given that, and see how you have an and. So this is more like a review. And so really what you should do is kind of like what I did when I did this in class, my remote class. I should like right now pause the video, and then you should try to do these three on your own, because really this is like a review. I already covered the or and the given that and the and. So it's like a review for you to see how much you've understood. So you really should stop the camera now and then just do these 3 problems. Take about 5 minutes for each problem or 6 minutes, for each problem and do those. And then turn the camera back on and then check your work as I do them. Okay. So I would recommend you do that. And then I'll see you in a bit. Okay, so now assuming you did follow my directions, you turned off the camera, you worked these three, you took about 30 minutes, right? Or 6 minutes per problem, 18 minutes to do that. Now we're going to check your work and let's see how well you did with your vocabulary. Okay. So one of the first things you'd have to do is you should get your totals. You need your denominator, so you need your totals. And when you get your totals, this number here will be your denominator for these 3 problems. So when I add up the numbers here, that you should have gotten 39. Here with the mugs, you should have gotten 46. Here for the candy, you should have gotten 43. Across for the coffee, that total should have been 66. Across for the tea, that should have been 62. And then when you add these totals, I should have given you 128. And when you go across, it should have given you 128. So hopefully you did that part. And remember on these problems, when you work on your computer, sometimes they don't even give you a table. Sometimes you have to make your own table. This one gave you most of the table, but even then you had to fill in your totals, okay? Okay, so then this one has coffee or cookies. So I'm going to do my outcomes for the coffee. And then this is an or, and then for the cookies. Okay. And because this is an or, I'm also going to keep track of my totals for these. Okay. So for the coffee, we have 20, 22, 24, and I'm going to keep track of my totals. So I put colon 66. And then for my cookies, I'm going to put 20, 19, and then my total is 39. And then when I look to see what I can overlap, I see how I can overlap the 20. And that's it, just the 20. And and so with the or, because we have an overlap, remember there's 2 types of ors. So this is the inclusive or, as opposed to the exclusive or. Okay, so I always think of exclusive, muy muy, exclusive muy muy. It won't associate, doesn't associate. So there's no overlap. Whereas the inclusive, it will, it includes it, inclusive. It will allow for that overlap. And there's an overlap that exists, and there's just one overlap. Okay, but with the or, what happens is you're supposed to um, sum the total outcomes And then you're supposed to subtract any overlaps because BC, because you don't want to count them twice. You don't want to count them twice. All right. So when I count my totals, I have, and here's my probably, right? So I'll put it right here. So I have 66 over 128 plus 39 over 128. And then I'm going to take away 20 over 128. And if I had another overlap, like let's say I had 22 here, and let's say I had a 22 here, if I had another overlap, then I would take that away. I would do minus 22 over 128 because I don't want to count them in both places, okay? And so I have 66 plus 39, take away 20. That looks like that's 85 over 128. I don't think that can be reduced because 85 divided by 5 is 17, and 17 is prime. I don't think 17 will go into 28. Yeah, it doesn't, not evenly. Yeah, so that you can't reduce that by 5. You can't reduce that by 17. So that's lowest terms. Okay, so I'm going to just leave it as a fraction. I'm not going to make it into a decimal and in a percentage. Okay. All right, now let's do the and next. Let's do the and next. So the and has t. So I'm going to do, these are the outcomes. So you have t, and then this is an and you have mugs. Okay, so for the t, where is the t? We have 19, 24, and then 19. And remember, this is an and, so I don't keep track of the totals. It's not like exactly like an or. I don't keep track of the totals for the and. Okay, the mugs I have 22 and 24. And when I look to see what I can circle, what I have is overlaps. It looks like I have the 24 as common overlaps there. And remember the definition of and for the and. So I'm going to say one overlap. So for the and, what you just do is you just sum any overlaps. That's all you do for the and you just have one overlap. So you just have 24. So this is just 24 over 128. Okay. And if you had another group circle, like let's say you had a 19 here and a 19 down here. Say you had 19s, then you would add, then you would do plus 19 over 128. If you had another overlap, you would just sum all the overlaps, okay? Now this can be reduced. Excuse me, can be reduced by 8. 24 divided by 8. 128 divided by 8. That gives us 3/16. This can also be reduced by 2 several times. 2 times 2 is 4 times 2 is 8. It actually became reduced by 2 3 times by 2. And if I do the math frac on this, 24 divided by 128 is this decimal. So I guess I can put that decimal here since I have it. Tens, hundreds, thousands. Look at the neighbors. A neighbor 5 or more. Yep. So add 1 to that. 7. And then if I do the math frac on that, math, and then the frac, so just hit enter, hit enter, hit enter, and then hit enter again. It reduces to 3/16. Okay, which was what we got. Okay, now for the conditional problem, conditional probability given that. So remember the T is the B given that A, the candy is the A. Okay, so then when we apply the definition, we're gonna let T denote, or let B, I should say, let B denote T is how I should really word it. Let A denote candy. Okay, that's what we did earlier, right, when we had to given that. Okay, and then I'm going to put down the definition. So probability of B given A is equal to probability of A and B over probability of A. So remember we said these had to match? Okay, so for us, we have, okay, I don't know, I'm probably gonna run out of room. Okay, so this would become, and I can change my ink, I guess, that would help. So probability of B is T given A is candy is equal to probability of A, which is candy, and B, which is T, all over probability of A, which is candy. So remember we said that these are supposed to be the same. See that? Okay, so then we need some work for the candy and T, and I'm gonna put it up at the top and go to the top. This is part 2 of 3 parts, and this was for number question 8. That's what it says here, right? Question 8. Oh, that's question 8. Okay, so I need the outcomes, and I've got candy and tea. Okay, candy and tea. Okay, so candy is 24 and 10, and tea is 19 and 24 and 19. And I'm going to highlight, let's see what's in common. The 24s. Candy and tea. I think I wrote the wrong number down for candy. It's 24 and 19. I think I wrote 24 and 10. Yeah, it's 24 and 19. So just be careful. Probably yawned at that moment. I made a mistake. Sorry. Okay, 24 and 19. And then the T, look at the T. 19, 24, and 9. Okay, so that's correct. Okay, and then what were you able to circle? We were also able to circle something else. So you have 2 overlaps. You have couple of overlaps. Usually it's just one overlap. We have a couple of overlaps. And remember what happens with the and. The and, you're supposed to sum the overlaps. Okay, so I'm going to sum the 24 over 100 plus the 19 over 100. And that gives me 24 and 19, 43, right? 43 over 100. Is that okay? All right. So then I'm going to use that. I'm going to grab that and I'm going to bring it back down here. And see, that's this probability. So now I have let's see. So I have in the numerator, I have 43 over 100 in the numerator, all over. And then the denominator is probably of candy. So candy, let's see, that would be 43 for candy. 43 out of 100, because that's your denominator. Okay. And right here, you can see the answer is going to be 1. You can see that this, and this just cross out. And really, that's just 1 equal to 1. That's our answer. But for the practice, like what I did on the other problem, when this gets rewritten, this fraction bar becomes the division symbol. So this would become 43 over 100 divided by 43 over 100. So this bar becomes this here. And then you change this to times and you flip this. So then you have 43 3 over 100 times, and then you flip this. You flip it. And then these right here, 10. So out, and that's a pattern. That's how you know you're on the right track. That's supposed to happen. That's how you know you're on the right track. And then you just, multiply straight across. 43 times 1. 1 times 43. And 43 over 43 is 1. Okay? And that's a logical answer. So remember, the definition of probability is they've got to be results that are between 0 and 1 inclusive, or you make them a percent between 0 and 100% inclusive. If you get any negative numbers, that cannot be a probability. If you get anything over 1 or anything over 100%, that's not a probability. That violates the rule for probabilities. So you can kind of get an idea and check your answer. If you're getting an answer in this chapter or in these sections, or this whole chapter is on probabilities. So on these probabilities, if you ever get an answer that's above 1, 1.1, 1.5, 2, you did something wrong, because they cannot go over 1 or over 100%. If you get anything under, you should not be getting negative numbers, okay? And then anything between 0 and 1 inclusive is allowed. Okay, so just keep that in mind. And so this is okay to get 1. Okay, so hopefully I did okay on that little review there. Okay, now this last concept is the concept of something called um, at least. You see this right here? Probabilities for at least. Okay, so the multiplication rules can be used with the complementary event rule to simplify solving probability problems involving at least. All right. So with the multiplication rule, that idea says that, and we're talking about multiplication rule number 1. That's what I wrote down here, is probability of A and B is equal to probability of A times probability of B. That's the multiplication rule. Then the complementary event rule is probability of E bar is equal to 1 minus probability of E. Okay, so we're going to make use of that definition too. Okay, and for what they're telling us, probability of at least what? This would be, here's the formula, 1 minus the probability of none, and that's usually raised to a power. N is a power. Or they might use 1 minus probability of all and use a power. Okay, so I'm going to show you some of both, and then you can see which one looks easiest. It depends on the situation also. So see if I can see where it says that. Let's see. Let's see. And the thing I was going to stress about this is the idea of not. Remember, this is not, and then this is. And then down here, let's see. Do I need to emphasize anything? Let's see. No, we're good. We're good on that. Okay. I thought I was going to say something, but no, I think that we're good on that. Okay. So then just keep that in mind. Vocabulary. I think I was going to say, yeah, that it depends on the situation. So, like, which one do I use, right? It depends on your situation. Okay, sorry. Okay, so it says here that the Neckwear Association of America reported that 3% of ties sold in the United States are bow ties. Okay, so I'm going to do this. Start with that. Probability of bow tie is equal to, I'll call that probability of B because they did use B here. And they said that was 3%. So as a fraction, that's, 3 over 100. As the decimal, 3 divided by 100 is 0.03. And then um, probability of no bow tie would make this probability of B bar, would make this by definition 1 minus probability of B, which by substitution would make this 1 minus probability of B. Well, probability of B is this 3%. So I'm going to do 1 minus 0.03. Okay, it's that. And 1 minus 0.03 is 0.97. Okay. Okay, so now when I find the probably, if 4 customers, so that's where the N comes in. This is the randomly selected, these right here. Has to do with randomly selected. So for us, we're 4 customers who purchase a tie are randomly selected. So we're going to be using to the 4th power for that. Okay. And so I'm going to write, find the probability at least one purchase a bow tie. So probability at least one bow tie. And this capital B. So probably at least one bow tie. Okay. So for at least, if I think about using one of these, and I have here bow tie, what's helpful is what's on the next page. On the next page, they have 2 more problems, but this I think is very helpful when they're talking about this. This is called probability for at least. That's what this is called. Probability for at least. It says here that it's easier to find the probability of the complement of the event. Okay, so it's easier to find the probability of the complement of the event. Let me write that down here. And so you can see here when I'm writing 1 minus, so the complement, 1 minus probability, and then I have no bow tie. So here it says at least one bow tie. This says none, no bow tie. And then which is would be referred to as none. And then I'm going to raise it to the in power for that. So I have 1 minus, and here probability of no bow tie, none. That would be, wouldn't that be this here? No bow tie, none. So probably of no bow tie, probably be bar. Okay, so this is going to be yes, so it's going to be this. So it's going to be, let me put in parentheses or brackets. 1 minus probability of B, and then raised to the fourth power. You remember 4 people were selected, randomly selected. Okay, so this is 4 randomly selected. So then it's 1 minus, and you have 1 minus probably of B, and probably of B, where do we put that at? What's our decimal on that? And it looks like probably a B is right here. So it looks like it's like 0.03. Raised to the fourth power. Okay, so if I do 1 minus 0.03, that should give me the 0.97, right? Let me see. 0.97. So that's 1 minus 0.97 raised to the fourth power. Sorry. Okay, sorry. So then let me use my calculator for that, and I'm going to use my exponent key. See my little exponent key here? So I'm going to do 1 minus 0.97, and I'm going to hit the raise to the fourth power, and then equals. Okay, so that gives me 0.11470719. And then if I multiply that times 100%, 100 as a percentage, that's about 11.5%. Okay. Okay, so let's go back and look at what we did here. See. So they say it's easier to find the probability of the complement of the event. So complement, involves the idea of 1 minus, right? Complement of the event. So here it says one has one bow tie. So complement then would be if you have one bow tie here, then right, one a bow tie, then you have none of them here. Okay. And then we put this in power from the multiplication rule because there's 4 people randomly selected. And so this would be 1 minus Probability of B. Okay. So 1 minus probability of B is 0.03. So we had that right here to the fourth power. And then we just typed this in one keystroke. Okay. And it gave us that. Okay. All right. So that worked out. That worked out fine. And if you think about it, this came from 97%. 0.97 came from the idea of 97%. So you see we had over here 3%, 3% and 97 is a total of 100%. Okay. Okay. All right. And we we didn't put any of these on the test, but there's one or two on your homework. So this idea of probabilities for at least, we didn't put any on the test for the probabilities for at least, but there's a couple on your homework though. Okay. All right. So let's see. Let me see if I can hurry up and finish this before I turn into a pumpkin. I'm getting sleepy. Okay, here we go. Excuse me, let's see. Okay, so here it's talking about coin is tossed 5 times, so that you know what your end will be. Um, Find the probability of getting at least one tail. And they're saying again, it's easier to find the probability of the complement of the event, which is all heads. And then subtract the probability from 1 to get the probability of at least of the at least tail is what they're suggesting. Okay. Okay, so these are definitions are familiar with. Probability of E is 1 minus probability of E bar. Probability of at least one tail, they're saying that's 1 minus the probability of all heads. Okay. And so you think of complement, what they're saying about the complement, because um, if you're saying tells, all tells, the complement of getting all tells would be no tells. Okay. So I think I'm gonna write something on the side here. Let's see. So I'm gonna say probability of at least one tell, and that equals 1 minus the probability of no tells. So if you get a tell, and then this is no tells. Okay, so I did the complement. So one tell, at least one tell, and this is 1 minus no tells. So then this is 1 minus the probability of that. If I go with that E bar, E bar tends to be that not, no tells. And then this is 1 minus probability and no tells. If you're not going to get tells, then that means you're getting all heads. Okay. And so then this is 1 minus all heads. Remember you have successes over outcomes. And remember, success would be a head over, you either have a tail or you have a head. So I'd be at a 2, so that'd be 1/2. This is 1 over 2. And then you would use to the power of 5. This is where the 5 comes in because there was 5 randomly chosen. Yeah, that should work. That should work then. So when we use these exponents, because that's part of the multiplication rule, then we're using the complement, okay? So it seems to work out for us. And then we can use our calculator on this. So this is 1 minus 1 to the 5th over 2 to the 5th. 1 to the 5th is just 1. 1 raised to the 1. 2 raised to the 5th. 32. Oh, and it's minus 1 minus 1 over 32. And this is 32 over 32. Excuse me, minus 1 over 32. And 32 minus 1 is 31 over 32. And that can be reduced. That's lowest terms already. All right. And let's see, I'm trying to think, was I going to put anything else on there? Try to remember. Let's see. They got the same thing here. Oh, they made it. They did make it a decimal, so I guess I could do that too. Let's see. 31 divided by 32. Tens, hundreds, thousands. Let's see. I think on this one I didn't do the. I'm supposed I didn't do the. Let me see. I think I typed something in, or I think I wrote it wrong, right? I don't know where I got the 3/6. Where did I get the 3/6 from? Where did I write that from? 31 divided by 32 is 0.96. I'm not sure where this came from. Where did that come from, class? I'm not sure what I did, where that came from. I don't see it on here. It's strange. Because 31 over 32 is 0.9, so I'm not sure where I got that from. Tens, hundreds, tens, hundreds, thousands. Look at the number to the right. Is that 5 or more? Yes, I'll add 1 to it. There, that's better. That matches better. Okay. Yeah, so you'll have a couple of these on your homework, but we won't put these on the test. These are a little more thought-provoking, and you just have to be careful. But basically, what you're doing is you're doing this. You're finding the probability of the event, which they said to find the probability of probability of the complement of the event, which is all heads, and then subtract the probability from 1 to get the probability of at least 1. Okay, so the idea is that it's easier to find the probability of the complement of the event. Okay, it's easier to find the probability of the complement of the event. Okay, all right. Okay, so now let's see. There's one more like this, one more involving this. So let's see. A medication is 69% effective against bacterial infections. Find the probability that, again, the N is 12 people take the medication, at least one person's infection will not improve. Okay, so you have here probably at least one will not improve. Okay, so this is equal to probability of E bar because it's got the not in it. And then this is equal to 1 minus probability of E. That's what that definition is. Okay, so then this is 1 minus probability of all. If this says uh, um, will not improve, this is all will all will improve. Okay, so then this is equal to, come back over here, 1 minus, I'm going to put open bracket, probability, and I'm going to put the definition I1 and I2 and dot, 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 I3. Okay, and then I'm going to take that all the way to, well, actually, since I did dot, 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 the last one would be, see, dot, 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 would be, and the last one would be I12. And then you want to close it. Okay. Okay, so let's go back to what we did. So here's the knot. Okay, and then 1 minus probability of E. It's just 1 minus probability of all will improve. This is not will improve. This is will improve. So not improve, and this is will improve. And then I'm using the multiplication rule number 1. So I'm using I'm letting let I, let me go back here. Let I denote selecting a person whose infection will improve. Okay. So that's what this I is, will improve. Okay, so then this is 1 minus, and this is going to be probability of I sub 1, comma, times probability of I sub 2, comma, times dot, dot, dot. All the way to the last one. I-12. Remember there's 12 people already selected. Okay. And then now I'm going to do my substitution. I'm going to substitute. And I come back over here. And I'm going to substitute this value here. Okay. Okay, so when I do my substitutions, I have 1 minus, and I've got 69% to the 12th power. And this is 1 minus 0.69 to the 12th power. Add out by calculator, that would be 1 minus 0.69 raised to the 12th power. And if I round this into thousands, tens, hundreds, thousands, and look at the rises, number 5 or more, yes. Okay, so now, I look at this. This is 0. This is 50-50 chance. This is 1, which is certain to occur. This is impossible to occur. Over here, you're sitting over here, it's unlikely. Over here, you're sitting over here, you're likely. And so this would be a highly 0.988. Okay, that's certain to occur. You're real close over here. This is a highly likely event because it's close to 1. Yeah, yep. So it's close to 0.988. That's real close to 1 on this side somewhere. So this is a highly likely event, and that's because it is closer to 1, which is the certain. So I have highly likely event. Yeah, because the 0.98 is somewhere way over here, right? 0.9 under the likely. So it's highly likely, right? Highly likely. It's closer to 1. Okay. So I'm going to put certain, I'm going to finish this thought by putting certain to occur. All right. Okay, let's see. And then those are the workbook problems. And let me see, I think there's a couple extra sheets. I don't think they'll take very long. It was just to help with your vocabulary if you type those out. Like this one, vocabulary. Let's see what that says. Mm. So are these two events independent or dependent? So you're tossing a coin and then you're drawing a card from a deck of cards. Okay, that sounds familiar. Let me see if we have those already. That sounds like let me go to the first page. That sounds like this one. Let's see. Tossing a coin, drawing a card. No, so it's similar to like this one. So here you're rolling a die and then getting a 6, but it's not exactly the same. They are different, but those are examples of independent events. Tossing a coin has no effect on the likelihood of the card drawn from the deck of cards, so it's independent. Drawing a card from a deck and getting a queen, and then you put it back, replacing it, and then drawing a second card, and then getting a queen. So those are independent. Replacing the queen and queen card returns the deck of cards to its original state, so that all probabilities would be the same as before. You'd still have the same odds of getting another queen card. Okay. And then these next three are going to be examples of dependent. So when the outcome or occurrence of the first event affects the outcome or occurrence of the second event in such a way that the probability is changed, then the events are said to be dependent events. One event is a factor that makes it either more likely or less likely for the second event to occur. So it says drawing a ball from a bag. You're drawing a ball from a bag. Remember, you're not putting that ball back. You're not replacing it. And then here you come along and you draw a second ball. So because you didn't replace it, not replacing the ball caused the probabilities for drawing the second ball to be changed. And these events are called dependent. Having a GPS in your car and getting lost while driving. So having a GPS in your car is a factor that makes it less likely for you to be lost. Okay? And so these events are considered dependent. Texting on your cell phone while driving and getting into a car accident. So texting while driving is a factor making accidents more likely to occur. These events are considered dependent. Okay, at the bottom it says two cards are selected from a standard deck of 52 cards without replacement. Find these possibilities. Okay, find these possibilities. Probably both of them are from the same suit. Okay, so when they say here without replacement, that means that these are dependent. Okay, dependent. And then we're going to use the multiplication row number 2, not number 1, but number 2, okay? Because they're dependent. Okay, so let S denote selecting for the same suit. Okay, so both of them are the same suit. So selecting from the same suit, both are from the same suit. And they're not talking about like a business suit or wardrobe. They're talking about the the suit. There's four suits. Um, there's four suits. There's the suits of diamonds, suits of hearts, suits of spades, suits of clubs. We're talking about, and you're choosing them all from the same, like all hearts, same suit. Okay, so we're going to have probability of S sub 1 and S sub 2. And we're doing 2 because 2 cards are selected like at random. Okay, so that's why we use 2. And then this is going to equal probability of S sub 1. And when you do your suits, um, the first time you choose a suit, it could be any of those. Let me look for my cards. Could be any of those cards. So the numerator is actually going to be 52. So I'm looking for my pictures. Where are my pictures of my cards? Uh, where are they? Sorry, let's see. Where did I put my picture of my cards? Let's see. Y'all have yours? Oh, here it is, way at the bottom. Goodness, sorry. Yeah, so they're going to be from the same suit. So the first time you pick a card, it could be any of these. Any of these. You're going to pick a card, and then whatever card you pick, that's the suit that you're going to have to stick with. So that's why that's going to be 52 over 52. Yeah. So for the first pick, any card could be selected. Okay. So for the first pick, any card could be selected. Okay. So that's why you have 52 to choose from over 52. Okay, now when you choose the second card, this is times P of S sub 2 given that S sub 1 has occurred. Okay. So this is going to be um, when once you pick the card, like let's say you pick a card and let's say suppose you get a heart. Well, now you've narrowed it down to the hearts. They have to be the same suit. Let's say the first card you pick, you get a heart, so you narrow it down to the hearts. So when you do your second one, now you're focusing on the heart. So there's 13, right? There's whatever you pick, there's 13 in a suit, whichever you pick. So then it's 13 minus 1 over 52. Okay, so then this would equal 52 over 52 times 13 minus 1 is 12 over 52. And whenever you um, whenever you multiply fractions, technically you multiply straight across, but remember this is actually 1. This is actually 1. This is actually 1. 52 over 52 is 1. 12 over 52. And that just gives you um, 12 over 50. Let's see, something happened here. 13 minus 1 is 12. Yeah, this should have been 52 minus 1. Because remember, without replacement. So once we get this card, we're not going to put it back in. So that's why this decreases also by 52 minus 1. So this gives me 51. And this gives you what? And that's 12 over 51. 1 times 12 over 51 is just 12 over 51. And I think that can be reduced by 3, right? Let me see. 12 divided by 51. Math. Frac. Enter. Yep. 4 over 17. 4 over 17. Okay. Because 12 reduces by 3. All right. Okay. All right. So again, it was 52 or 52 because you want to draw 2 cards and they want to be from the same suit. They didn't restrict it at first. So at first, any of those cards could be picked. But once you pick a card, suppose you pick some kind of a heart, now you're restricted on the same suit. This has to be from the heart as well. But it's 13 minus 1. This card is not being replaced. So 13 minus 1 is 12. And of course this has to decrease also. Okay. And then you end up with that. Okay, and then the last page. Scientific study. There's 8 guinea pigs. 5 of them are pregnant. If 3 of them are selected at random without replacement, find the probability that all of them are pregnant. Okay, so without replacement, that means these are dependent events. And that means that we're going to use multiplication rule number 2. And that says probability of A and B is equal to probability of A times probability B given A. And we're going to let P, does it find the probability that all of them are pregnant? See, all of them are pregnant. The G denote selecting a pregnant guinea pig. Okay, so we have probability of G sub 1 and G sub 2 and G sub 3 because we're selecting 3 of them randomly. And then this is equal to probability of G sub 1, G sub 2 given G sub 1. Probability of G sub 3 given that this previous has occurred. Okay, now, so when we talk about the first fraction with the guinea pigs, there's a total of 8 of them. So that's your denominator. But the top, you're interested in the ones that are pregnant. And then once you um talk about that guinea pig, that particular guinea pig, and you're not putting that guinea pig back in the stash. So remember what we said, this idea. Remember I used these earlier. These are olive seeds. 5 of them. Just 5 of them. 5, 6, 7, 8. So you have 3 over here. 5, 6, 7, 8. So you've got these 1, 2, 3, 4, 5 guinea pigs. And then you're going to select one. Okay, and now you're left with 4 of them. So this is going to be 5 minus 1 over 8 minus 1. 5 over 8 times 4 over 7, because you're 4 being 1, 2, 3, 4. You've taken this one away. That was used for this first selection. And here are the other 3 back here. And then when you pick the third one, it's going to be 5 minus 2. 5 minus 2. So 5 minus 2 is 3. 5 minus 2. This is 8. 8. 8 minus 1. 8 minus 2. 8 minus 2 is 6. So 5 eighths times 4, 7 times 3, 6. Okay. Yeah, so then here when you choose this guinea pig, then you're left with 3 left here. Okay. And so then when you multiply across all your fractions, you should get 60 over 336. And when you reduce it, so let's see, 60 over 336. When you reduce that, use your math frac, and you should get 5 over 28. Can you check that if you're getting that? You should get that. That's what I got on mine. Okay. So you see how these decrease. Okay. All right. One more. One more. Okay, so this is a conditional probability, and this should have been more of a straight line. So this should have been more like this. This means given that. And again, remember how these match. We've got these blood types, okay? And there's some blanks. We need some blanks filled in. So I think this is exactly how I typed it from the ebook. I think they made a mistake. I think they should have put a percent here, but this should have been 5%. This should have been here 15%. This should have been 100%. That's your denominator. And they want the probability that you have type O blood given a rhesus plus. Okay. Okay, so this is O, this is you're going to be your B, and then this is your A. Okay. And this means given that, it should be like a straight line here. Given that, given that. I'm sorry. Okay, so let P denote type O. Let A denote the rhesus factor, RH plus. Okay. And then when I do my vocabulary, so I have my vocabulary up here. So I have probability of B given A, so I have that here. And now I'm going to do this part. Probability of A is RH plus, and B is type O, all over probability of A, which is RH plus. Remember this pattern? That looks good. It's supposed to be the same. That looks good. Okay. And so now, see how I have this set up? Because see, this is the and. So RH plus events, I'm looking at 37, 34, 10. I leave the 85 out because it's not an or. If it were an or, then I put it down. Okay, and then the O events are right here. 37 and 6. I left off the 4. I left off the 4 right here, sorry. Okay, now what can I circle? What can I circle? Looks like I can circle the 37s, but that's about it. Okay, one overlap. Okay, so then this is going to give me 37 over the denominator, which was 100%. So 100 all over. We lower this. And then I want RH positive, which is RH positive, 85%. Okay. Over 100, right? Because there's 100 total. Okay. And this can be rewritten as 37 over 100 divided by 85 over 100. Change division to times and flip this. And then these will cancel out. And that's how you know you're on the right track, because that's supposed to happen with these. So you end up with, these are little ones. So this is 37 over 85. Okay. 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 So that concludes my section. So hopefully that helped. You can work on your homework now. Okay. All right. And I'm just double check one last time that that was correct answer, because I was very sleepy. But 37 over 85 is 5 over 28. And then the other page, let's see, was there another page? The first one's 4 over 17. Okay, just double checking. Make sure I didn't write down the wrong event. Okay, it's correct. Okay. Okay, good luck with your homework then. Take care.